Welcome to Innovate and React. I'm Kevin Hares, and today I'm here in Düsseldorf at the Chemical Industry Disrupt 2026, hosted by ChemStars. With me is Dr. Rhea Machado, the CEO and co-founder of Porelio. We will talk about Porelio's solution for removing forever chemicals from our drinking water. Welcome, Rhea. Thank you so much for joining me.
Yeah, it's a pleasure to be here.
First of all, let's start a bit about Porelio and what does Porelio do?
Yeah, so we are a spin-off of the Technical University Berlin, and our idea origin at our PhD time that Javier, our co-founder, he's our CTO, had his research time. He was working on catalysis, and for catalyst you need a support material to put the active sites on the surface, and he was working with functionalized ordered Meso-Porous silicas, which have an ordered pore structure and functionality on the pores, so they can catch the active sites, and then you get a catalyst. And this material is really hard to produce, so he was in lab for 1 week producing maybe 5 grams. Super nasty, but these materials are brilliant, so they were the gold standard in many fields in chemistry, so for catalysis, adsorption materials. And he was like, why we can't use them for the industry if there's such a great material? And then he saw, okay, it's because long reaction time, a lot of toxic solvents, and also the raw materials were very expensive. So he finished his PhD lab time, and then he went back to the table and said, okay, I want to change that. And he had an idea, he pitched it to the Technical University. They said, it's genius, let's try it out if we can make them scalable. They funded us with the first 200,000 euros, and we were able to do the proof of concept that we can produce these materials. And there I joined, basically, because he is a chemist, he's really brilliant in the lab, but if you want to bring something into industrial reality, you need to scale it up. And I'm a process engineer. I did my PhD also at Bascat, which is a joint lab between BASF and TU Berlin, and I joined the team and we built our pilot plant. And then, just to finish the round sentence, we had this idea, we got the money also from the state to scale it up basically and to make the validation, but it's a platform solution. You can use it for adsorption, you can use it for catalysis, and we had to find a market which has need to find a solution, and also of course to be big enough to accept also innovation. And that's how we got into the PFAS topic, basically.
Oh, very interesting. So the material itself can also be used for all kinds of applications, but you were looking for one that needed something new, and this was a new application also for this material?
Yes. So if you look into the PFAS topic, I mean, we can find now everywhere PFAS in our waters at different concentrations, and we understand more and more as a society that they are toxic. And the industry in the last 50 years came up with more than 10,000 different PFAS chemicals, and they can be very long, with a long carbon chain, or very short. And for the short chain that are also more and more present in our waters, there's no solution out there. Activated carbon fails, ion exchange resins fail, especially for the ultra short chain PFAS. So we saw a huge potential with our material to solve that.
Yeah, that is especially in the recent years there was a huge discussion about these PFAS because there were all these negative implications coming up, and suddenly we were looking more into it, and then people discovered, okay, it's actually everywhere, in every person, and that probably also through the water we drink, right?
Yes, through the water we drink, but also the food we uptake. So especially in meat, there's a lot of PFAS because it accumulates in especially animals that we eat, like cows and pigs. And this is a huge problem because even unborn get it through the blood of the mothers.
Yeah. And then that's where they're most vulnerable. Probably.
Exactly. And it was a blind spot for a long time. So the industry found this amazing material actually, because it's repellent against oil, against water, heat resistant. It's really like the holy grail of all what you can think about coating and sealings, and it's used everywhere basically, and also some very important fields like
implants, something like that.
Implants or for surgeries, and many fields we can't get rid of them, and we have to find solution how we at least prevent that they are not leaving the chemical plants and form like in the wastewater, for instance. Because this at the end ends up in our waters and comes back in the drinking water, but also of course in core plants and animals.
So you're also addressing water treatment plants, for example, when there's a chemical site and they have their standard treatment plant. I would say they catch most of the chemicals, but the PFAS materials, they go right through.
Yes. Half and half, I would say. They're like this long chain PFAS. They're also the most damaging, and activated carbon is already widely used, especially for the drinking water facilities. They have now to check the limits also, and it's cheap and it does the work. That's actually already good news that we have, at least for the long chain PFAS solutions. But the shorter it is, the more difficult it is, because it behaves more and more like also like the salts that are in the water. And then there's starting a competition between the salts in the water and the PFAS.
And I think also the longer chains are getting smaller and smaller in the treatment plant, and then the end you have the C1, C2 PFAS, which are the most difficult. And this is where your material then comes in and can catches those, right?
Exactly. So we are focusing first in the industrial wastewater, because there you're going to have higher concentrations also, and we do believe that as a first step, we have to stop that they're getting into our waters. And also there are many sources where, especially like TFA, the shortest chain PFAS, is generated through, for instance, PFAS membranes that are widely used in the chemical industry. And there we are talking really high concentration of PFAS. We're not talking anymore nanograms per liter, but micrograms per liter, even milligrams per liter, where TFA is emitted, and there we want to develop a solution.
How does your material, these Meso-Porous silica, how does that interact with the PFAS to catch it?
Yeah, so we can put various kind of functional groups on the surface. We can really engineer it. And since we have this ordered pore structure, that makes the mass transfer very fast through the pores. Because usually adsorption materials like activated carbon or the ion exchange resins, they are coming with an unordered pore structure, like a sponge you can imagine. And we are ordered in the nanoscale. And you can imagine like a German Autobahn. I like to give this example because everyone could understand how efficient it works. And since you have like this Autobahn and with, let's say, chemical arms on the side that catch exactly what you want to remove, because you engineer the surface, you can be then much more selective and also faster. And that is one of our strong, unique selling points, that we are much, much faster than activated carbon or ion exchange resins.
Faster in the sense of that you don't need as a big package of the active materials?
Exactly. At the end, it's about contact time. So you have to ensure that the contact time is enough for catching this PFAS. And of course, you have a certain volume that you have to treat per hour. And how you can modify the contact time in that way is that you build big systems if you have long contact times, or smaller systems for shorter ones. And the faster adsorption process is, the smaller you can also then design the plants, and the lower is then also the investment for the treatment plants.
Yeah, because then it needs to use less. And you mentioned that you can engineer the pore structure. So is the interaction also a physical one, or is it actually a chemical interaction?
It's a chemical interaction. So the pores are big enough for letting the PFAS molecules, but also the other potential ions through. That's important. Then it's a chemical interaction at the end, or physiochemical.
Okay. And that's these end groups that you are able to engineer, which also could be used for catalysis if you have then an active
part. Or one other vertical of ours is the capture of precious metals also from complex industrial streams. And then depending on what kind of functional group you put, you can choose which of the molecules you want to capture.
Oh, okay. That's how you tune the chemicals you can get out with this end groups.
Yeah, I'm do like the little joke, it's kind of Tinder for chemistry because you are creating a platform where they can meet the filter and the molecule that has to be removed, recovered.
Perfect match then.
Exactly.
You can just tune it to what you want it to be. Quick break. First of all, thank you for tuning in. This really means a lot to me. I would like to ask a small favor from you. It would really help if you could follow Innovate and React on whatever platform you're listening. This helps to reach more people and spread the amazing research of my guest further. Thank you so much for your time. Back to the episode. When you want to apply this material now, you said already the chemical sides, but what about water treatment that prepare our drinking water? Is this also feasible there, or are the concentrations already too low?
It's not about the concentration only, it's also about the co-contaminants. And we have, depending on which region you're in Germany, very high concentration of sulfate, for instance, or it's like the hardness of water, like if you're in Berlin, you just use some water and everything is white, basically. And that makes it more challenging to remove, especially short chain and ultra short chain PFAS. And this is a challenge that we still have to tackle to find the right material. For industrial wastewater, we do see that there are different challenges, but that are the ones that we want to tackle first.
And where do you see now the biggest challenge that you have to overcome to scale your material?
That's a very good question. I would say not the biggest challenge, but it's like all connected challenges, because at the beginning you have a rough estimate how much your raw materials cost at the lab scale, and then you can also make an estimate with the economy of scale about the raw material in the larger scale. But how to scale it up then in practice and how much your material would cost, this is something that you do your first estimation, and the more you scale it up, the clearer is at the end the cost structure. But at the same time, you need to make the unit economics for your customer right. And that's, I think, a challenge for a startup that is always there, how to be very precise and also how to talk to the customer with to be an ally, because of course you need customers that are innovators and want to try out your material, and it has to be a strong partnership. But at the end, we're startups, so we can't promise Lanxess a ready material. And we have also to find the right partners to scale it up. We can build our own production plant, or we go with custom manufacturing organizations. And this is a way that you have to go. Then you're a small team at the beginning, so you can't have the whole expertise. You have to find the right people that help you to get consultancy also, so that you go to the right direction. And you have at the end to juggle everything, the scale up, the regulatory pathway. We are talking, if we produce beyond 1 ton, about REACH, and finding the right customers, scaling up the application and scaling up the production.
And both simultaneously.
Exactly. It's sometimes I feel like it's not about chemistry, it's like an orchestra. And everyone is playing another instrument, but somehow it has to sound good.
Yeah, especially when scaling up something that doesn't already have a market, because it's a new technology in the water treatment, as you said, then you have to do everything at the same time, this kind of chicken and egg problem, where you basically need customers, but they want to already have proof, and then you can, with only new customers, get the proof, and then that's sometimes difficult. But I think that also offers a big chance, because a new customer at this stage can also get the probably really tailored material for their application.
Yeah, they are then in the pole position, it's clear. I mean, obviously every startup works a bit different, but for us, if we have a partner at the very beginning and gets the support, of course, we will prioritize this person or the company. And it's a challenge to find the right company, but also then the right company with the right people. Because at the end it's all about the people that are working there. Do they have this innovation-driven mindset, or are they more really on the efficiency side? Because at the end you are talking to R&D people, they might be a bit more open. But if you're talking then to the process engineer, this process engineer, he wants to have running systems. And he will not just commit to a new technology if he's not really sure that when he's implementing the system that he's not going to have headache. Because if we cause downtime to his systems, this is not what he wants. And this is a huge barrier for chemistry startups, especially if you're in the B2B. If you have an end product, I think it's a bit easier.
But in this sector, that's probably difficult to have an end product.
Yeah, I mean, I know some startups, they are like in the field, for instance, of cosmetics or oils, where you're really very close to the end product, let's say. If you're like in the downstream process, or even, I would say not much worse, but much more challenging if you think about the pharma industry and you're in the GMP area, it's another challenge.
Yeah, but that might also be, you mentioned the precious metals that they use as their catalysts, but sometimes they actually avoid precious metal catalysts because of these very low limits they have in their products. And that, I think, would also be a very interesting
we're talking
application.
also to customers that have that kind of challenging streams, especially if they have to remove from the product stream. So they can't apply high temperatures, for instance, just to evaporate or whatever to get the catalyst out. And there are different cases, but it's also difficult to identify those cases, because at the end you have to be the painkiller and not just a vitamin.
Okay.
And you have to identify these painkillers in the industry. And of course, it's also the truth, the chemical industry doesn't want to talk about pain.
Yeah.
Like, they have their problems and they work on the problems, but they're not going out and say we have this problem. I can see it with the tech industry. My husband works in the tech industry and also in the AI field, and you can see like how much more open they are. They have their meetups, they're talking about different challenges they have hackathons and so on. We don't have it. I mean, we are happy that we have now that kind of chemical disruption day where the industry is coming together and is talking to the startups. But ChemStars is just 5 years old, and that has a reason, because we are just starting to be more open about our challenges in the chemistry.
Yeah, definitely. That's also a development that I see now in the discussions with other founders and networks I had so far, that over the past years a lot of movement is coming, and this is also, I think, with the current economic challenges that the chemical industry has, they just don't have another choice than to innovate more again. And startups are a great example of how new technologies can be tested, and they have maybe also their research and development, but to implement something in this huge organizations it's much more difficult, and startups can really move fast in this way.
I do believe also that the timing is great for chemical startups at the moment. The state is helping us with a lot of public fundings pre-incorporation, which is very important, like Exist research transfer, for instance, is a great tool. And also the universities understand now that they need to support with expertise, so the professors get more awareness that they can support startups. In TU Berlin, we build now a whole building for green chemistry startups. So if you're a student, a PhD student, or also even masters, you have your great idea, you apply to it and you get a free lab. And this is genius, because that's what we need.
No. It's also another way of output from this really good research apparatus, I would say, we have here in Germany. And the output then is not publications, but these companies and startups.
Yeah, because I think there's also a little conflict of interest of the big companies. They usually, or most of the patents, if they have money, they do them to dry out the competition, right? Okay. Which is smart, of course, because they have their core business, it's running, they make money with it, it's efficient. Why they should really disrupt the industry. And then you have the startups that might disrupt it, but if a patent is generated in the company, the likelihood is low. If it's generated in the university and they give the chance to the students to use it really to deploy this patent, then we can, and there are many of that kind of startups, because we know also like one startup will not solve the challenge that we have. We need hundreds of startups that the most successful are then getting out and is changing the chemical industry basically.
Yeah, definitely. I think that's also what we have seen over the past years in the automotive industry, where they really were still pushing these internal combustion engines, but everywhere else basically they were pushing for EVs, and now all these German car manufacturers have problems. And this is also because they wanted to stick to their old model, and in the chemical industry it might be similar.
Yeah, and I mean with that kind of event we're here where actually the startups meet the big companies, let's say, you see that there is an interest also of the companies to look into innovations. And I mean, it's chemistry, we are all innovators, right?
Yeah.
We all love science, we all love to see more efficiency. Also, I mean, if you think about catalysis, there are some established systems. If you just achieve 2 or 3% more selectivity, so much more CO2 you can save and money, of course they are also interested.
Yeah. And also new materials, like all this material science coming from chemicals, like you did, for example, where we really get new materials that also really disrupt the status quo in that sense. So where do you see the vision for Porelio? Where do you see you going in the next years?
So our vision is that we bring to the industry more efficient separation technologies, that they get an instrument that they can use to recover metals, to get rid of the PFAS, and we are part of the solution that we as a society face. And of course we want to scale up our production. That means we want to get to the ton scale in the next years. We want to find the right customers to go with us this way, and I think for the next years that's already enough. We just closed our first fundraising round, so there's manpower and money to do that. And the vision is, of course, that in a few years we go to the seed round and then Series A and find the right people to go with us the way. Yeah,
that sounds as a great way to proceed, and for that also events like today are very interesting to connect with other founders, and maybe even with corporations you can then achieve that goal even faster.
Yeah, and you can have cooperations with other startups. Sometimes they have a challenge that we can solve, or other way around, and then two very innovative units are working together. And it's a bit also like a class meetup, because you know actually already some chemical startups, and then you meet them again, you ask how are you doing, what are your challenges. You can be open, you know, like you exchange. I have also, for instance, a WhatsApp group with female green chemistry founders.
Cool.
So it's a German-wide, and we're writing inside if there's a challenge or if someone has a recommendation, and we are growing as a community. And it's also important, I think, not only for female founders, but also to have the community for everyone. So we founded the Association of Industrial Green Chemistry, and we just started it to get really European-wide all startups together to have also political voice.
Yeah, that's a very important thing.
Yeah, because for us it's important that it's recognized that the way is long. So we started with the idea 2018, so it's almost 9-8 years old, and it needs also long funding times. And for instance, if you're funded, only the first 3 years you can get the biggest funds, but 3 years is nothing. And then you're out already, and then you struggle, and I think that has to be changed. It has to be acknowledged by the European Union that we need more time for that kind of challenges.
Yeah, there is this gap between the proof of concept and the large scale production, and that's also what I had in previous discussions, that this is really the point where a startup might fail or might really have a big win, but I think we could have a lot more of these big wins if the system would change a bit. And then as you mentioned, these networks are great for that. And also, how do you with this network then also go to the EU Parliament, or what?
Yes, this is our interest to establish a voice for green chemistry startups in Europe. So it can be also national-wide. I mean, the German government has every year a get-together of the chemistry industry where they discuss their challenges and what they need from the government, and we need to have a chair also there. because it's normal that they have a lot of people that they employ and that they are listened, but we need to be listened to.
Yeah, because as a whole, it's also a lot of people then. Do you think that especially the green chemistry is also represented by the bigger companies, or is this more in the startup scene?
I think there are some efforts, of course, and there are also big companies that are more into the green chemistry field or have products. I think also that the consumers, they are looking for solutions. Like if you think about outwear coatings, they're like, I hope that I spell them right, VD or VOD. They do like, you know, the tents and the backpacks, and they already have now PFAS-free coatings. And of course they did it because the consumers say, hey, I go to the nature, I don't want to create damage to the nature, so they had to find solutions. And that's why we need to discuss also with the end consumers, producers, how we can deliver them solutions. Yeah,
definitely. It's always about finding a solution, and then there will be customers eventually. Right, and now that we're slowly coming to an end of this discussion, do you have some tips for future founders who think they have a great idea in the lab and they want to bring this to application?
Yeah, I think first of all, find your allies. Find the professor who wants to support you, because you need a lab, you need someone who gives us expertise and will also push you. Then get connected with the community, because we already did a lot of mistakes, and I think I'm very happy to tell what kind of mistakes I did, so you can do at least different ones. And find your mentor, find smart people, find the old people, I would say to them, like who are in the mid-50s, have a lot of experience in the chemistry field, and they're happy to support you also. And be a bit of naive, it's important, because it's a huge challenge. If you think about this huge challenge in detail, you will not start this journey.
Yeah, that's a good point. I think getting started really is an important point, and not to sit in your chamber and just think about it and until it's 100% solution, that will always take too long.
Exactly. Go out and talk to the customers also. Because
exactly.
You're not having a product and then it has to fit to the customer. The customer has a problem and your product has to fit.
And it's also not always that it has to be completely entirely new. It can just be an improvement on the status quo. Then thank you very much for your time.
Yeah, I just want to say, if you're in Berlin, we would love to invite you, of course, to our labs to show you also our pilot plant.
Oh yeah, that would be very interesting. Thank you very much. Also, thank you so much for listening. If you want to learn more about water treatment and Porelio's special Meso-Porous Silica, visit their website with the link in the show notes or contact Rhea on LinkedIn. If you made it this far into the episode, you are the kind of person I'm doing this for. There's now a way you can support the show. By going on Buy Me a Coffee with the link in the show notes, you can chip in a one-time amount or become a subscriber of the show. Thank you so much. Keep innovating and stay curious.